So now we're going to revisit equilibrium. So we just saw the Kw arise before. Now we're going to talk about Ka and Kb, which are the acid dissociation constant and the base dissociation constant. So let's check our phases here. So the acid will always be in aqueous phase. Water is always in liquid phase. Hydronium is in aqueous phase. And your conjugate acid is in the aqueous phase. So let's write a generic K expression. You have concentration of products, which is concentration of H3O plus times concentration of A minus, which is your generic conjugate acid, divided by that, these are all at equilibrium, by the way, sorry for that, divided by that of your HA, which is your generic acid reactant. And keep in mind, as I said earlier, we are not including water ever because it is in the liquid state. And K expressions only take into account aqueous and gaseous states. This is your Ka because it is the acid dissociation constant. As you can see, we are using acids here. Excuse me. And over here, we have your base. So this is acid dissociation, and this is base dissociation. So these are extremely generic reactions in chemistry, just very generic. You're not showing any actual compounds, you are just showing, generic acid reacts with water to form hydronium plus conjugate, base reacts with water to form hydroxide plus conjugate. So again, we have our phases here, aqueous, 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 and a liquid on H2O as always, which will not be included in our Kb expression. So we are left with this. So this is basically it for basic everything that falls under the umbrella of acids and bases for the introduction. This will be part 1 of acid-base chemistry. Stay tuned for part 2 and part 3. Thank you.